SQL versus NoSQL, the Architect's Guide to Modern Data. Welcome to the Masterclass. Today, we are covering one of the most critical decisions in modern software architecture, SQL versus NoSQL. On one side, a structured, relational world of tables. On the other, a flexible, non-relational universe of documents, graphs, and key-value pairs. We'll cover definitions, differences, and exactly how to choose. Let's begin. Every app is built on a mountain of data. Think about what runs behind your favorite apps. Billions of photos being stored, millions of financial transactions being processed every second, global product catalogs being served to customers worldwide. All of this is data, and it all needs a foundation. Choose that foundation wrong, and the entire system breaks under pressure. The two dominant approaches to modern data. Every database in the world today falls into one of two camps. SQL, structured query language, organizes data in a relational, table-based system. NoSQL, not only SQL, takes a completely different non-relational approach. They are not just different tools, they are fundamentally different philosophies about how data should live and breathe. SQL builds a rigid, reliable foundation. SQL is the original, battle-tested approach to data storage. It organizes everything into strict tables made of rows and columns. Think of it as a super-powered industrial-strength spreadsheet. Every record has a defined place. Every column has a defined purpose. It is rigid by design, and that rigidity is exactly what makes it reliable. The SQL mental model, tables and keys. Here is how SQL thinks. Data lives across multiple tables. A patient's table, a doctor's table, an appointments table. These tables connect to each other through shared IDs, and keys lock all that data together, enabling 4 core operations on every record: create, read, update, and delete. That's the relational model in action. The schema demands a perfect blueprint. Before a single byte of data enters an SQL database, you must hand it a complete blueprint, called a schema. Every table, every column name, every data type must be declared upfront. Once frozen in place, changing that structure is costly and slow. But the reward is a database that is strict, predictable, and highly organized. SQL superpower is absolute accuracy. SQL's greatest weapon is ACID compliance, the gold standard for data integrity. Atomic, every transaction is all or nothing. Consistent, data is always valid. Isolated, transactions never interfere with each other. Durable, data survives even system crashes. Every transaction is 100% guaranteed, or it rolls back entirely. No half measures, ever.
The web scale crisis demanded a new paradigm. In the early 2000s, the internet exploded. Companies like Google, Amazon, and Facebook were suddenly managing data at a scale nobody had ever seen before. Traditional SQL databases simply couldn't keep up with the sheer speed and unstructured nature of the modern web. The industry needed something fundamentally new. And so, NoSQL was born. What is NoSQL? The paradigm shift. NoSQL stands for not only SQL, and it throws out the rulebook entirely. No fixed tables, no rigid columns, no predefined structure. Instead, it's built from the ground up for data that is unstructured, rapidly changing, and massively scaled. Where SQL draws hard lines, NoSQL draws none. Flexibility is the entire point. NoSQL Family Part 1, Flexibility and Speed. The NoSQL family starts with 2 powerful members. Document databases like MongoDB store flexible JSON-like data. Each document can have a completely different structure, perfect for content and user profiles. Key-value stores like Redis store simple, unique key-value pairs, optimized for lightning-fast retrieval, perfect for caching and real-time session management. NoSQL Family Part 2, Scale and Relationships. 2 more members of the NoSQL family. Column family databases like Apache Cassandra store data in columns rather than rows, purpose-built for reading and analyzing massively large data sets at high speed. Graph databases like Neo4j store data as nodes and edges, built exclusively for mapping complex, interconnected relationships like social networks and fraud detection systems. NoSQL superpower is limitless expansion. Here is the defining difference in how each system grows. SQL scales vertically. You upgrade one server's CPU and RAM, but there is a hard physical ceiling to how powerful one machine can ever get. NoSQL scales horizontally. You simply add more servers to the network. More traffic, add more nodes. The scale is essentially infinite. Head-to-head, data structure. First direct comparison, data structure. SQL requires a costly upfront definition of every column and type. Once that schema is frozen, altering it is painful and slow. NoSQL adapts instantly on the fly. You can store completely different types of data in the same collection without ever predefining the structure. Maximum flexibility by design. The trade-off, perfect accuracy versus ultimate speed. This is the most important philosophical difference between the two. SQL follows ACID, guaranteeing perfect accuracy at every single moment. A bank transfer cannot fail halfway. NoSQL follows BASE, basically available, soft state, eventually consistent, deliberately trading split-second perfection for extreme speed and availability. Different goals, different guarantees, different use cases entirely.
Head-to-head, query complexity. Now let's compare what each system can actually query. SQL is a master of complex operations, deep joins across multiple tables, intricate filtering, aggregating dozens of conditions effortlessly in a single statement. NoSQL is optimized for fast, direct lookups, getting to one piece of data instantly. But complex multi-collection joins, in NoSQL, they can become nearly impossible. The architect's cheat sheet. Here is the complete side-by-side summary. SQL uses tables, a fixed schema, vertical scaling, and strict ACID consistency, best represented by MySQL, PostgreSQL, and Oracle. NoSQL uses documents, key-value pairs or graphs, a flexible dynamic schema, horizontal scaling, and eventual base consistency, best represented by MongoDB, Redis, and Cassandra. Save this slide. Where SQL dominates the real world. When does SQL win? Every time accuracy is the only metric that matters. Banks, financial institutions, and hospitals worldwide rely on PostgreSQL and Oracle for exactly this reason. A single error on a bank transfer is unacceptable. A corrupted patient record is dangerous. In these environments, ACID compliance is not optional. It is the entire foundation. Where NoSQL dominates the real world. When does NoSQL win? When scale is measured in the hundreds of millions. Netflix uses Cassandra to stream to 230 million global subscribers simultaneously. Instagram uses NoSQL to manage billions of photos. LinkedIn uses Neo4j to power social connections across hundreds of millions of users. Unstructured data at this scale demands horizontal, limitless expansion. Polyglot persistence, the plot twist. Here's the truth the industry has learned. The smartest engineers don't pick a side. Modern enterprise architecture uses both. SQL handles order management and payment processing, where strict transactional accuracy is critical. NoSQL handles product catalogs and real-time shopping carts, where massive flexible scale is what matters. The two databases run side by side in the same application. The architect's final takeaway. And here is the lesson that ties everything together. SQL, structured, strict, reliable, is the right choice for money, healthcare, and complex queries. NoSQL, flexible, fast, limitless, is the right choice for social platforms, real-time apps, and massive scale. The right database is the one that fits your data. Pick the tool, not the trend. Thanks for watching. If this video helped you, please hit like button.